It's going to take a look at naming for those of you who are on remote. So we have been doing kind of a dichotomous key on how to name compounds, and we are only going to be working on some simple compounds. We will only do binary ionic compounds and binary covalent compounds, along with polyatomic ions. We won't be doing any organic or anything like that. We'll save that for more advanced chemistry when you get there. So the first question you ask yourself when you go to name something is the compound ionic or covalent? So ionic or covalent is your first question. You know it's ionic if it contains a metal and a nonmetal, or if it contains a polyatomic ion. So I'm going to write that here, metal and nonmetal, or polyatomic. Your polyatomic ions are listed in the back of on the back of the periodic table, and there's a few exceptions to this that we'll get to in a little bit, and those include acids. For ionic compounds, there are two types, and the question you ask yourself is, does the metal have more than one type of ion? So more than one type of ion. And so we'll do yes over here, and we'll do no over here. Now, I have a much nicer version of this that I made with the computer, so I'll share that with you as well. So more than one type of ion basically means, on the no side, that means it's group 1, group 2, or one of the few exceptions that are listed on your periodic table. So that would be silver ion, aluminum, cadmium, and zinc, and those are all on the back of that periodic table listed for you. The ones that have more than one type of ion are the transitions and the post-transition metals. So both of these are named very similarly. There's just one exception for the yes column. So on the no side, you're going to name the metal as an element. So you just use whatever the element name is. So pretty easy there. Then you name the nonmetal. For the nonmetal, you change the ending of its name to IDE. So for example, if you have oxygen, oxygen becomes oxide. So nothing too crazy there. On the side where there's more than one type, you're going to do the same exact process. So name metal with its element name. Then in the second part, you're going to add a Roman numeral in parentheses that tells the charge of the metal. Charge of the metal. So you have to work backwards from the nonmetal to figure out its charge. Then you're going to do the same thing you did before. So for the nonmetal, with its IDE ending. So let me give you an example of this real quick. So let's say we have something like CuCl2. Okay. First, I know it's ionic because it contains a metal and a nonmetal. Second, I know it is the type that has more than one type of charge. I typically call those type 2. And I know that because copper is a transition metal and it's not on my list. So I have to figure out what the charge of copper is so that I can name it. To do that, you're going to start with your nonmetal. So chlorine has a 1- charge, but the subscript means I have 2 of them. So that means I have a net -2, which means this one must be a +2. So this is copper 2 chloride. Now, some modern books are leaving off the parentheses, so it's okay with me if you do leave them off. I think that's coming soon that we won't use those parentheses at all, but that's what I was shown, and so that's what I'm going to do for now until somebody tells me different. Now, there's another version of this compound that's copper 1, and it looks like this. And so you can see here, this is where the copper would have a 1+ charge. This would be called copper 1 chloride rather than copper 2. So I'm going to label this side type 1 and this side type 2. Now let's go over to the covalent side. Let's see if I can get it to move for me. Maybe I can. So the covalent compounds are a little different. The first question you're going to ask yourself for covalent compounds. Oh, I forgot to mention, before I move on, I forgot. Polyatomic ions. Polyatomic ions, there is no name change. You can't change the name of a polyatomic ion. So if you had nitrate in the compound, it's just going to be nitrate. You're not going to change it to nitride because that would be nitrogen as an ion. So that's not going to work. So on the covalent side, your first question is it an acid? Is it an acid? Now, for Chem 1, here's how we distinguish whether or not a covalent compound is an acid. So your question is really, is the first element hydrogen? Okay, so this side is going to be our no, and this side's going to be our yes. Okay, so on the no side, here's where you're going to have only nonmetals. Okay, and it's not going to start with hydrogen. So for example, these are things like CO2 or NH3. Over here, you're going to see things like HCl. I also always in Chem 1 put an AQ behind it like this, just to help you distinguish that that's going to be an acid. Now, acids are really weird. We'll talk about them in a little bit. They're technically covalent, but they behave as if they're ionic. They're polar covalent compounds, so they're really strange, but we like them, so we are going to name them. Now let's go back to the no side. Okay, so for covalent compounds, there are no charges to let you figure out these subscripts. So on the ionic side, when you have the name of a compound, you can still write its formula because you know what their charges are, and you know how to use the charges to set the net charge of 0 to know how many subscripts there should be. Covalent compounds don't have that. So when you name them, you are going to name them in such a way that people can figure out what it's going to be. So here's what we're going to do. So first, name the first element with its element name. So just like the other ones, you're just going to say this one's going to be carbon. Now, you're going to add a prefix if there is more than one atom. Okay, so I'm going to get to that in just a minute. Let me go ahead and write the second part. So the second part, name the second element we're going to use the same rules as before with an IDE ending and we're going to add a prefix with the amount. Now on the second one, you do go ahead and put mono if there's only one. So let me write down all these prefixes for you. So 1 is mono. Most of them you'll know from math, but some of them are a little different. So 2 is di. 3 is tri. 4 is, I just tried to mess it up here. It's not quad like it is in math, it's tetra. So tetra. 5 is penta. Let's see. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. and 10 is deca. Now, we're not going to go past 10 in our class. Now, remember, we're naming very simple covalent compounds. When you move on in chemistry, if you move on in chemistry, you'll learn how to name organic compounds, which has its whole own set of rules, but we're not going to do that here. So now remember, the key thing to remember for these is that the first element, you're never going to have a mono on the first element. We just don't put it on there. I don't know why, that's just the rules we use. For the second element, you always will use a prefix on the second element. So there's always going to be a prefix on the second element. There will only be a prefix on the first element if there's more than one. So let me do an example here for you. So let's say we had something like C2O4. Now, it's not a real thing. I just made that up, okay? So I'm going to name the first element, and you can see it's just carbon, and I'm going to use the prefix di. So I'm just going to call it dicarbon. Now I'm going to name the second element. It's got a 4, and that prefix is tetra. So it's dicarbon tetraoxide. Oops, my pen kind of went crazy there. So that's how you name those. Now, the one we had before, CO2, we would just call it carbon because we do not put a mono, and we call it dioxide. So that's one you're familiar with. And you're probably pretty familiar with this one too. Carbon monoxide. Bad stuff. So you can see these, as long as you know these prefixes, you'll be fine. Okay, so now let's go over to the one that's a little more challenging. This one is acids, and it just takes a little bit of getting used to. So when you are given a compound, and the compound is all nonmetals, so here's an all nonmetal one, and usually I put an AQ behind it in parentheses. Now remember, AQ means aqueous, so acids are covalent compounds that have been dissolved in water, and when they're dissolved in water, they do something weird. They pretend as if they're ionic compounds, and they actually dissociate into ions. Now, we are talking about strong acids when we do this. Weak acids actually don't completely dissociate, and so that's what makes them kind of an odd little bunch. So, for acids, you have to ask yourself a question. And so the first question is, does it contain oxygen? So, oxyacids, those that contain oxygen, are named differently than non-oxy acids. So we're going to do a no on this side, and we're going to do the yes on this side. All right, so on the no side, okay, so here's what you do. You're going to add the prefix hydro. Then you're going to add the root of the anion's name. Then you're going to have an IC ending, and finally add the word acid. Now, I like to do these with just using a example. So let me get rid of this so it's out of my way a little bit, okay? So here's my example that we're going to use. We're going to use the one we put at the top, HCl. So all acids that are oxyacids, that are not oxyacids, are going to have a hydro, the root of the anion name, an IC, and then the word acid. So this is going to be where the root is. So here's what that would look like for this one. So this one has chlorine, so the root's chlor. So we would call this hydrochloric acid. Okay, so let's say we had HF. Root fluor, so it would be hydrofluoric acid. We had let's see, 2S. So you can have more than one hydrogen there because this one, you kind of pretend it's an ion when you do it. So if I have H2S, this would be hydrosulfic acid. Sometimes we call it hydrosulfuric acid, just depends on how you like to say it. So those are the ones that do not contain oxygen. if we go over here to the ones that do contain oxygen, these guys can be a little trickier, okay? So let me see if I can get myself organized here. There we go. All right, so the ones that contain oxygen, these, you need your polyatomic ion sheet for this because you have to look at the name of the polyatomic ion that's in it. So think about it this way. HNO3 and HNO2. Okay, so they contain all nonmetals and they start with an H. So anything that starts with an H for us in Chem 1 is going to be an acid. Now, that's not entirely true. We use that for Chem 1. Please know that if you go on in chemistry, you'll learn more about what makes an acid and the different definitions we have for acids. However, for our level right now, this is a decent enough rule that we can use. So when you look at this one, you can see it contains hydrogen and it's a polyatomic ion NO3 with it. And normally we think polyatomic ion must be named like ionic compounds. But instead they're going to be named as acids here because they start with that H. So the first thing you're going to do here is look up the name of the anion. Now hopefully you know some of them already from your work with ionic compounds, but you might not. So here's what you're going to do. If the name ends in ATE, you're going to change it to an IC. If the name ends in ITE, you're going to change it to an OUS. Then you add the word acid. So let me show you this one. So the two examples I wrote up there were HNO3 and HNO2. If you look up NO3, you will see that it is nitrate, and NO2 is nitrite. So all you have to do is look at this and change its ending to whichever one it is. And there's several mnemonic devices that you can use. I know there's plenty on the internet you can use. This one becomes IC, and this one becomes OUS. So this is nitric acid, and this is nitrous acid. Okay, let me give you another example. How about H3PO4? Okay, I know it is an acid because it starts with that H, and I usually go ahead and put that AQ behind it just to help you out. So again, I can see it contains oxygen, so I'm just going to look up PO4, and PO4 is phosphate. So this is going to be phosphoric acid. Now, some books will actually go ahead and make it phosphoric acid because the original was phosphorus, but it doesn't matter to me which one you choose, which one you use. It's fine with me either way. So some things are old enough to where they have their own names outside of the systematic naming. So this is a systematic naming we're using. So for example, this one we used earlier, NH3. Now this one's not an acid because for our explanation for why it's not an acid is that it doesn't start with the H. Okay, the better explanation happens to be with what it does when you put it in water. But for right now, we're just going to say it doesn't start with an H, so it's not an acid. This one, if we name it systematically, would be nitrogen trihydride. However, this was around long before these rules for naming were around, and we more commonly know this as ammonia. All right, that's the bell, so that's my cue that it's time for me to be done. We'll be doing more practice in class, and so hopefully this will help you guys on remote. I will get more information out for you soon.